Welcome back, my friends, to your channel. Today we are going to continue to talk about IP address and subnetting, and we are going to talk mainly in this video about DHCP. But please, before we start, don't forget to like, share, and subscribe. As most of you know, we have 5 classes for the IPv4 addresses: class A, B, and C, which are the most used classes for our subnetting and IP configuration, while class D is for the multicast IP, and class E is for testing in the laboratories. First of all, we are going to talk about unicast, multicast, and broadcast, and to see what is the difference and the main difference between broadcast and multicast. Mainly, as their name states, unicast is sending a packet from one to one, from a server or a computer or device on the network to another device on the network, while multicast is sending from one device to multiple devices, while as the broadcast is sending from one device to all the devices in the network. So mainly, the main difference between a broadcast and a multicast is that in broadcast, when a packet is sent from the source to the destination, it reaches all the destinations, all the devices in the network, no matter what device is on the network. And then each device may accept the packet or reject it according to the need. While in a multicast, the packet is sent from the source will reach only multiple devices on the network. Think of the multicast is like a source of water, and anyone who requires to get some of this water, he will bring the bucket to this source and get its need. So mainly, the packet of multicast will be produced on the network, but it will not go to the devices as in the broadcast. It will not reach all the devices, while as the device who requires to have this packet will start searching for this packet and then take it. So now, moving to the main idea of the IP subnetting. So why is the need for IP subnetting? One of the main important things of subnetting is that it minimizes the broadcast in a way that when we subnet our network, and each several devices will be on their own subnet, then the broadcast among our network will be minimized, and thus traffic that passes through the network will be minimized, which will make the network performance better. Now, moving to talk about special addresses. As most of you know, the private IP addresses, and as we talked in the other video, we have private IP addresses of the classes A, B, and C, which are used in the NAT part for network address translation, while as we have special IP addresses, as you may see in the image. We have the IP addresses that is 127.0.0.0 till 127.0.255.255.255. Those addresses are used for diagnostic, which means, for example, if we go to 127.0.0.1, this is the local host of any device, of any computer or any server, which means when you type to ping 127.0.0.1, or you request to access 127.0.0.1, you are requesting to access the same device that you are inside it. And we have 0.0.0.0, which is any network on the internet or in the local network, which means that to access any internet, any network. If you go to your command prompt, for example, and type router print, you will find that you will have the 0.0.0.0 destination, which and you can reach it through your gateway. As well, we have the network broadcast, which is 255.255.255.255, which means to send the packet to all the devices in our local area network. And basically, this is how the DHCP works actually. Any new computer or server that you start on your network, it will send a broadcast packet to all the local area network, is telling them that this is my MAC address. Please, anyone knows my IP address. And this packet will reach all the devices in your LAN, and only the DHCP server will accept this packet and then return to to the requester its IP address. In case the DHCP server is not available, then the device, the requested device, will take something called a pipa, which is this also a special IP that starts with 169.254. This special IP address, as I said, it's called a pipa. This means that there is no DHCP server in your local area network, or the DHCP server is not available to respond to this device. If the DHCP server is available, then you will get a NAT IP, which is a private IP address from the classes A, B, or C, depending on your DHCP server. As you may see in the image, the difference between the APIPA IP and the DHCP reply IP. Now, to install the DHCP DHCP on your server, you go to add roles and features, and then you follow the steps in order to install the DHCP role on your server. And then once you finalize the steps, you will have the DHCP server ready. Then you will go and open your DHCP server, and you will start the configuration. Now, to start the configuration, you right click on IPv4 and you go to the new scope. In order to add a new IP address scope, you will name it and put description if you want. And then you will follow the steps to start to put the start IP and the end IP, from where you want your private IPs to begin and where to end. And you will specify also the subnet mask as well, which give you by default. For example, now when I put 192.168, it gave me the 24 over 24, which is the default. I may change that to 25, 26, or maybe 22 if I want to have more IP addresses. After that, we'll go to the next step. After specifying the subnet mask, we'll go to the next step, where it will ask us to exclude from the IP addresses. For example, if I specify from 50, from 192.168.5.50 to 192.168.5.100, and then I want to exclude the IP 55, I may put it here as a single IP, or maybe I may exclude a certain range, for example from 5 to 10. I don't want these IPs to be given to any devices, because I want to use them as static IP addresses for certain devices. I may add this exclusion here, and then I will go to the next step, which it will ask me to specify the time that the IP address will stay defined on the connected devices. When a device connects to my DHCP address and take this IP, I may specify to, by default, it will stay for 1 day. I may reduce or add more time to that. And then I will go to next step, where it will we will reach to define the gateway for our range, for our DHCP range, which is the default gateway to be given to the devices. Once I specify this gateway, I'll go to next step. In this step, I will specify the DNS server, which will resolve my IP to address to name. I may add as much DNS servers as I want, and then I will go to the next step. Here I will define my WINS server if I want. Otherwise, I will go to next step, to the final step here, where I will finalize with enable or disable this scope. If I may start with disabling it and then enable when I want it to start to be active. By this, we will be finalizing the IP addresses and subnetting, and we have talked about the DHCP. I hope it was clear enough for you, my friends. Please don't hesitate to ask any question, and please don't forget to like, share, and subscribe.